So we're looking at page 25 in the course notes. We're going to skip over number 1 because that's a question that was designed for in-person learning, and we're remote this semester, so that's not going to fly. All right, so we're going to hop to number 2. A person observes a busy intersection with a traffic light for a period of 10 minutes during rush hour. 200 cars drove through the intersection during this time. Of those 200 cars, 30 cars ran a red light. All right, so number running a red light. Number that sped through yellow. Is 50. And the number that did both, so number running red and sped through yellow, is equal to 15. What percentage of cars did neither? All right, so we'll get this in the proper notation here. We'll call this R for red, Y for yellow, and this is R, and this is an AND situation, so it's intersection. So we have kind of the makings of a Venn diagram. So R, Y, and this would be my R intersection Y. That's the overlap between the two. All right, so they're telling us that 30 cars ran a red light. All right, so the number of cars running a red light is 30. So I'll just kind of jot it in there. Number of cars running or speeding through the yellow is 50. And then 15 did both. Now the total number that we have is 200 cars. All right, so that's 200 available. So we would want to know how many we have in total. Well, we already know that, actually. I apologize. I just got distracted for a second. So we can take the sum of these two numbers, 30 plus 50. That's going to give you a total of 80 cars. All right, if you tack on to that the 15 that's doing both, you're up to now 95 cars. All right, so we want to know the percentage of cars that did neither. So if we take that 95 and subtract it from the 200 that's available, that's going to give me 105. What that's equal to is the cars that are not red, and I keep saying not red, they're not red cars. No, the cars that did not run a red light, and cars that or cars that did not speed through the yellow. All right, so that's going to give us all this stuff out here. All right, the notation isn't overwhelmingly important in this problem, but trying to get an understanding really is. All right, and so since we know that the whole shebang adds up to 200, then that would mean that the probability of getting a car that did not run a red light or speed through a yellow would be equal to 105 over 200, which is about, if we're going percent form, about 52.5%. All right. Number 3, a card is selected from standard 52 card deck. find the probability of either a 7 or an ace being selected. So the probability of getting a 7 or an ace. All right, so I look at my 7s, I look at my aces here, and then I would ask myself, well, is there a way that you could have a card that's both a 7 and an ace at the same time? So we would actually have no overlap. All right, so that's how I designate it. Really, in general, you should have two distinct circles that do not overlap one another. But in lieu of doing that, what I just generally do instead is I just make a little note that there's no overlap. You know, even though the diagram would have overlap. So you could write it either way. You know, I'm sure other teachers might have different policies and stuff. I'm fine in terms of the diagram, as long as you have the general understanding. So if you're looking for the probability of getting a 7 or an ace, you just need to simply add the probability of getting a 7 to the probability of getting an ace, because there is no interaction between a 7 or an ace. If you have a 7, it can't be an ace. If you have an ace, it can't be a 7. These are what's known as mutually exclusive events. All right, so there's 4 cards in the deck that are 7s. There are 4 cards in the deck that are aces. Add them together, that's a total of 8 cards in the deck that are either. All right. Now, if you're talking about 7s and reds, there is overlap. Because you could have a card that is both a 7 and a red at the same time. That's the overlap. That's a possible case. All right, so if I were to do what I just did, find the probability of getting a 7 union red, I might say find the probability of getting a 7, 4 out of 52, plus the probability of getting red, which would be 26 out of 52. Where are these numbers coming from? Well, we could look at the sample space. I'm going to flip there in a second because I want to show you something. But this is actually going to be incorrect. It's incomplete, right? Because we have to account for the fact that when I counted up all my 7s, I actually counted up 2 of the reds as part of that process, because I'd have my 7 of clubs. Get ready for this diagram. That's a club. 7 of spades. But then I would have my 7 of hearts, 7 of diamonds. All right, so I'd count up all my reds. So there was 26 of them. But then I also double counted, you know, among those 26 were the 7 of hearts and 7 of diamonds. So I accidentally double counted those. But I can correct for that by subtracting off the overlap. 7, the union, or the intersection of 7 and red, which would be 2 out of 52, which would give me 28 out of 52, which would be the correct answer. All right. Another way of handling that would be to go to the sample space and say, all right, I need red cards. All right, where are my reds? I've got them all right here. All right, those are my reds. All right, on top of that, I need all my 7s. So let me get my 7s. So now I would just be looking for any unique value in this set. So I'd say, okay, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. I missed one. 28 right there. All right, so a total of 28 cards in the deck that are either 7s or red. but that relies on you having the sample space in front of you. All right, so one way or the other, you have to have a sense of the sample space, but in this case, it's not, you know, too challenging if you just